Well, the funny thing is that we actually still just make it all up. And why I'm excited about this talk is it actually shows that we actually got it right. We heard from Gary how marine protected areas can be a really great strategy for conservation, and they're being used all around the world. But how successful the MPAs are depend really on how well they're designed. So over the last few years, a whole bunch of scientists have been trying to work out what's the best way to design a marine protected area or an MPA. And they've developed all these principles for MPA network design. And there's lots of them. We need to take into account biology and physical processes and socioeconomic characteristics. But one of the ones that's really important is that we recognise that we need to understand and incorporate biological patterns of connectivity. Now, all that means is, for example, on a coral reef, we need to understand how everything moves around. So we need to understand how the fish move around within a reef and how they move around between reefs. So that, for example, if one reef gets wiped out by a cyclone, then we know that reef's going to be recover because it's going to get other fish coming from other reefs. Sounds pretty good, right? Great idea. No one knows how to do it. So what we did is that until just recently, we have the methods now, but until just probably a year or two ago, we were still making it up as we went along. And what we did is we devised these things that they call rules of thumb for marine protected area network design. And that says if you really have no clue and you don't know what you're doing, which is the case in most places in the world, you can just use some general guiding principles. And if you want to take how fish move around into account, we can give you some general ideas about how big the marine protected areas should be and how close they should be. And you know, of course, everyone had all these great ideas, but no one actually had any data to show that it worked. So what do? We use these rules of thumb. And there are essentially two types. One, it says if you're going to do a marine protected area, you better make it big enough so the fish that are swimming around actually stay in the marine protected area and not too many of them go outside where they can be caught. So you need to make them at least 10 square kilometres in size. The second thing you need to do is think about how far they are apart and how far the fish are going to swim among these MPAs. So you need to think about spacing of them and make sure they're about 15 kilometres or less together. Really good idea. Does it work? No idea. But people around the world are really excited about establishing networks of marine protected areas. And in the last few years, we've all just started to do it based on these principles. A couple of years ago, we designed a marine protected area network up in Kimbe Bay, up in Papua New Guinea. And amongst other things, we used those principles for MPA network design. And what you can see here is this is the Kimbe Bay network. All those black boxes are where we hope to establish marine protected areas. And what we did is we actually used those principles. So this one down here, that's about 10 square kilometres, so it's about the right size. So you can see most of them are the right size or bigger. And then we did the spacing and we thought, okay, they've got to be closer to 15 kilometres or less to the next one. And these two over here, those two there are 15 kilometres. So you can see they're all pretty close and we did the right thing. You know, no idea if it was going to work, but that's what everyone told us to do, so we did that. And then we had the biggest stroke of luck. And what happened was that some scientists from that's right, we had no idea it was going to work, but we did what we were told. And so we had this big stroke of luck because some of the scientists from the Centre of Excellence in Townsville were actually doing this really cool, innovative research where they were actually working out for the very first time how you track the movement of fish around. And weren't we lucky that they decided to do it in Kimbe Bay where we were working. And so what they did is a whole bunch of fish and a whole bunch of methods, but I'll just give you one example. Does everybody know this fish up here? Nemo. So they decided to do a study of Nemo. And what they did is they did something called DNA parentage analysis. You know when there's all those paternity tests about, is he the father of that child? Well, they did that with the fish. And so they did is they went to Kimbe Island, which is this place out in the middle here, and they did a DNA profile of all the adults on that island. And then they looked around to see where all the they sampled all the babies from Kimbe Island and these other 3 MPAs around to see how many of the babies came from Kimbe Island. And what they found was really remarkable. It's so exciting. They found, maybe just to me, but it was very exciting. One of the things they found was that up to over 40% of all the babies that arrive at Kimbe Island actually came from there. And that's much higher than we expected it to be. And so that's good news, because it tells us that if we're able to protect Kimbe Island, you know, there's lots of self-recruitment happening, and so that's a good thing. But the really exciting thing was they found that up to 12% of all the babies arriving in these 3 adjacent MPAs also came from Kimbe Bay. And that is really, really fantastic, because it's the first data in the whole world that shows that these rules of thumb for MPA network design really work. And not only were we ecstatic in Kimbe Bay, because, oh my gosh, we actually got something right, but we were just thrilled to bits, because I work with people in many places around the world, particularly in Indonesia and other places in the Coral Triangle, where we're designing these rules of thumb based on our best guess. And it's tremendously exciting when someone does some really fantastic science and tells us we actually got it right. So just to finish, it's not only really exciting that this happened in Kimbe Bay, but what's really exciting is people all over the world are using these principles. In fact, they use them here on the Great Barrier Reef. And so it's good news. It means that we're actually on the right track. Thank you.